Hi, welcome to my channel, JaberTime. Today I'm going to go over the rate of change, the average rate of change, local maxima and minima, the absolute maxima and minima, and increasing and decreasing. Rates of change and behavior of graphs. Rate of change. A rate of change describes how an output quantity changes relative to the change in the input quantity. The average rate of change between 2 points or two inputs values is the total change of the function values, output values, divided by the change in the input values, which is actually what we call it the slope. Change in y over change in x. That is called the average rate of change. Of course, when you go from one point to another point on a curve, on a graph, it doesn't go straight like a straight line with it, which is a fixed slope. But on average, you could find the slope of that secant that intersects those two distinct points. Given the graph of the function g of t, find the average rate of change on the interval from -1 to 2. Now notice that -1 is x1 and 2 is x2. Once you locate them, you could go up to the graph and locate the y coordinates, the y values that corresponds to the 2 value and the -1 value. I have them -1, 4 here, and 2 and 1. So this is an interval. That means this is x1 and this is x2. So once you locate the points on the graph, x1, y1 is -1, 4, and x2, y2 is 2, 1. One way to do it quick, if you want to do it without mistakes, if you could locate or write x2, y2 on top and x1, y1 at the bottom side, this way you could see the y's are aligned and you could subtract them, and the x's are aligned and subtract them. So we have f of x2 minus f of x1 over x2 minus x1, or differently in short we call it y2 minus y1 over x2 minus x1. Applying the numbers right here, 1 minus 4 will be on top, 2 minus 1 will be at the bottom side, as you could see. Simplify, and I have -3 over 3, which is -1. The graph shows that overall the slope is -1, but that's the secant. The slope here is greater than -1 and negative value, like -2 and -3, but it averages because it goes back up. We're going down 3 and to the right 3, which gives me a slope of -1 over 1, which is a -1. So the average value is actually the slope of the secant, this red line that connects this point and this point. After picking up a friend who lives 10 miles away and leaving on a trip, Anna records her distance from home over time. Find the average speed over the first 6 hours. Now notice right here, we are starting at 10. After picking up a friend who lives 10 miles away, that's right here, and after 6 hours, we are at the mileage or miles of 292. So we need to consider these 2 points, that's x1, y1, and that's x2, y2. The average speed is the average rate of change, which is the slope, as I mentioned. So we have 292 minus 10, that's the y values, over 6 minus 0 for the x values. Simplify, and you get 47. What does that mean? It means that the average speed is 47 miles per hour. Well, of course, she's not going maybe exactly 47 miles per hour every single second. Sometimes maybe higher, sometimes lower, but it averages to 47 miles per hour. What's a local minima and a local maxima? A function f is an increasing function on an open interval if f of b is greater than f of a for every ab in the interval where b is greater than a. That means b is greater than a, like 7 and 5, like, you know, going from 5 to 7. So 7 is higher. F of 7 would be greater than f of 5. As you go to the right, your values are increasing. It will be decreasing if f of b is less than f of a. As you move from a to b, f of b is lower in value. A function f has a local maximum at a point b in an open interval a to c if f of b is greater than or equal to f of x for every single point x where x does not equal to b itself in the interval. It will be a local minimum if it's lower than in value than f of x for every x in the open interval. Those are definitions, but let's take a look at some graphs. Graphs will help a lot understand what's increasing, what's decreasing, what's local max and local min. I have a graph here that shows this portion right here is increasing. A, B, B is greater than A. So as you move to the right, f of b is greater than f of a. That's increasing. Also, this portion right here is increasing, where the middle one is decreasing because you're going down. As you go on the right side of x, or x values increases, you're going up, then down, then back up. You're increasing, then decreasing, then back increasing. There's more details right here, as you could see. The first portion on the left, you are increasing from negative infinity to this point, which is -2. F of b is greater than f of a, where b is greater than a. Those are definitions. In my graph, the function is increasing from negative infinity to -2. We're looking at intervals, we're not looking at the y value. And decreasing from -2 to 2, then increasing from 2 all the way to infinity. As you could see, I'm reading from here, I'm not reading the -16. So, once it's increasing and decreasing, this point will be the maximum point, the turning point, in an open interval next to it. We call it local maximum equals 16, the value of it, and that occurs at x equals -2. On the other hand, this point is the lowest in an open interval that contains it, so we call it local minimum. The value is -16 and it occurs at x equals 2. So the function right here, graphed, which is x cubed minus 12x, is increasing on negative infinity to -2, as I mentioned, union 2 to infinity, this portion and this portion, and increasing in the middle between -2 and 2. This would be a good definition of local maximum. Once you are increasing, then back decreasing, this point will be called local maximum. Same applies for local minimum when you go down, then back up. Find all local maxima and minima of the function f in the graph. Well, the graph right here shows that we're going down, then back up, then down, decreasing, increasing, decreasing, increasing, then decreasing again. This would be a local max at 1 and the value is 2, the maximum value. This would be a local minimum, and the local minimum occurs at -1 and the value is -2. So the graph of f has a local maximum at x equals 1 because it is the highest point in an open interval around x equals 1. The local maximum is the y coordinate, which is at x equals 1 and the value is 2. We just mentioned that. The graph has a local minimum. Now we're looking at this point at x equals -1 because it is the lowest point in an open interval around x equals -1. The local minimum is the y coordinate, which is -2, and that occurs at x equals -1. Here's some quick graphs to help you understand more about increasing and decreasing. The constant function is neither increasing nor decreasing. The function that is called identity, y equals x, it's increasing all the way from -infinity to +infinity. The function y equals x to the second is increasing from 0 to infinity and decreasing from -infinity to 0. And we have a local minimum at x equals 0. The cubic function is increasing all the way. The reciprocal function 1 over x is decreasing, also decreasing on its domain, and that's why it's written this way. The 0 is not included. Okay? The reciprocal squared function 1 over x to the second is increasing here and decreasing here, increasing from -infinity to 0 and decreasing from 0 to infinity as open intervals. The cubic root is increasing all the way. The square root, it's increasing on its domain from 0 to infinity. Now let's talk about absolute value, absolute maximum and absolute minimum. The absolute maximum of f at x equals c is its output, f of c, where f of c is greater than or equal to x, or f of x, for all x in the domain. So it's the max. Nothing is higher in value than the value of f of c. It's the greatest. F of c is greater than or equal to f of x for all x. Same applies for the minimum. So the absolute minimum will be when f of d, at d here, they don't want to pick the letter c again, when f of d is less than or equal to f of x for all x in the domain. This graph here does not have an arrow right here. It doesn't go all the way to infinity. So it stops. That means nothing is above it. F of 2, which is 2, is the greatest. It's greater than or equal to all f of x in the domain from -1 to 2. So we call it the absolute maximum. This point is the lowest in its domain, in its graph. So we call it the absolute minimum. That is f of 0 equals -2. This point will be called local max. But the focus on this example is about absolute and absolute, max and min. This point is max because in its interval, it's a maximum point, but it's not going to be the greatest as the absolute max. This would be the absolute max. Find absolute maximum and absolute minimum of the function f graphed right here. Notice we don't have arrows right here. It stops. Let me show it to you quick. This would be local min. This would be local min. This would be local min, local max, and local max. But since these are both at 16 and nothing above them, they could be also called absolute max. This one here, it's the lowest in all the domain or all the function. Yeah. So f of 3 is -10, and it's less than or equal to f of x for all x in the domain. We call it absolute min. Given the graph P of t, I need to find the intervals of increasing, decreasing, and the local and absolute extrema. This one has arrows, as you could see. That means before we start, it doesn't have an absolute max. Okay? I would say before I show you the notes that this is a local max, this is a local min, This is a local min, but this would be the absolute min. Here we go. This is decreasing, decreasing, and I'm writing the answers for you. This is increasing, increasing, and I'm giving you where it's increasing from 1 to 3 and from 4 to infinity because it does have an arrow. And because of these two arrows, we don't have an absolute max. This point is a local min, but it's also an absolute min at 1, -1. That should do it, and thank you for watching. I am recording another video right after this one, and I'm doing my best not to make it too lengthy, like 16 minutes or about. I think it's enough for increasing, decreasing, and maximum and minimum. Thank you. Thank you for watching. Don't forget to hit the like button, subscribe to see some more, and I'll see you in the next one.